Hi, my name is Tig Hips.
Hi, my name is Sindhu.
Hi, I'm Ben.
My name is Rushir.
Hi, I'm Braden, and we're Code Rush.
For our first year Engineering Design Day project, or FEDD project, we were tasked with designing and building a mechanical vintage tabletop arcade game that is creative and fun, utilizes luck and skill, and has at least 4 different power sources, all within a budget of $40. We like the idea of pinball, that's been done many times, but we wanted to do something different and make it more unique and original. Before we could start creating, however, we had to complete the first step of the engineering design cycle, research. Pinball machines peaked in popularity in the 1970s, providing entertainment for people of all ages. These machines used flippers to propel a ball around the playfield, aiming to score points by hitting bumpers, targets, and other obstacles. We used this research on how these mechanisms work and implemented that knowledge into our project design.
After researching, we moved on to the second stage of the design process by imagining and brainstorming various ideas for our arcade game. We spent about 3 weeks brainstorming and analyzing various games to see what design choices worked and what didn't. We thought of ideas like traditional pinball but the area of play rotates, a game where you drop a ball, a game where you whack something with a hammer, and a sort of tilting maze game inspired by Nintendo Land's Donkey Kong Crash Course minigame. We ultimately decided on a fusion of pinball where you could tilt the area of play and sort of pachinko sprinkled in, and we wanted flippers that you could use to launch some object. We decided that having a coin as the actual object of play instead of a ball would be really interesting, since that's kind of a callback to arcade games requiring a quarter to play.
We finalized our arcade game Quarter Rush to be a tilting maze game that implements the mechanisms like flippers and other obstacles. To start the game, a quarter is inserted into the slot at the top of the frame. Players will grab onto both sides of the frame where the handles are and rotate it to guide where the quarter goes. The buttons are pushed to move flippers inside the frame to launch the quarter around the various obstacles. With skill and some luck, the player will try to guide the quarter as far right as possible before it falls to the bottom. The player would be scored by the amount of distance they were able to go in the maze. With a final design in mind, we moved on to the next stage of the design cycle by planning out the implementation of the machine and splitting it into essential layers, including the game board, backboard, and tilt mount. We worked to further refine ideas and how the project was going to be built and created a plan to organize a schedule for the final 4 weeks.
After making several different drawings and diagrams in our meetings, we started to finalize elements in our game design. For the next stages of the design cycle, creating and testing, we decided on building a prototype, making changes, and building the final game layout based around the adjustments made to the prototype. Our prototype consisted of 3D printed pieces that serve as platforms pinned to a poster board so we could easily manipulate and change the game layout. We used this prototype to test the gameplay and fine-tune the positions and angles of the pieces. This prototype gave us a rough idea of how the game functions.
After making the prototype, we moved on to the last stage of the design process, building and improving. All of our sketches and designs were combined to make one giant CAD assembly containing the cabinet, buttons, and flippers. The CAD model was created using the exact measurements of the materials we had, so everything in the model could be cut, constructed, and assembled exactly as designed. With the design finished, we could start on actually building the parts, starting with the cabinet. Since the cabinet was primarily constructed with wood, it required cutting. Lots and lots of cutting. After the wood was cut, the cabinet could be assembled with the plexiglass cover, game board, and backboard all in place. Next up was the flipper assembly, easily the most complex part of the design. The general idea for the flippers was that the user would push the button down and a hinge connected to a rod would convert that vertical motion to horizontal motion. Next, the horizontal motion would be translated to rotational motion by a pin slot joint, making the flipper turn when the button was pressed. While simple in concept, the buttons had to move multiple rows of flippers, which added numerous complications later down the line. For example, the rows of flippers were joined together with a large array of rods that connected to both buttons and would move together as a singular unit. As I discovered, these rods aren't perfectly rigid like they are in CAD, so the assembly didn't move at all initially. However, I was able to improve the design by improvising and finding something that was rigid.
In this case, it was these paint sticks I found in my garage.
With enough force, the flippers were able to move and the project was finished. The only thing left was to present it at FEDD.
For my advice to incoming freshmen when it comes to FED is I would not procrastinate. Our final product, we want to be so much more, but we just never really adhere to our deadlines as we should have.
Always try to be ahead of the game. You always gotta pretend like your deadlines are sooner than they actually are, because things will almost always take longer than you think they will, and you always want that extra time to fix things up and make sure it's actually working completely.
Sticking to deadlines and avoiding procrastination are key aspects of FED.
Stick to your schedule that you make, because if you don't, then you're going to end up stressing yourself at the end and it won't be as fun as it should be. You can put your FED project on your resume, so do something that you like, something that you're passionate about, something that aligns with your major, because you would be able to stand out to employers that way.
Start early and start building your prototype early. There's going to be a lot of different considerations and complications that arise as you're building that you never even considered to begin with, and those are going to add a lot of time.